Next speaker, very pleased to introduce Morten Lindberget from CondAlign. And Morten will talk about room temperature electronics bonding in flexible hybrid electronics applications addressing sustainability cost.
Thank you for the introduction. Good afternoon, ladies and gentlemen. Thank you for the opportunity to talk here. It's actually my first post-corona talk in the US. It was a little exciting as well. So today I will talk about our technology, a little about the company, our products and applications, and you will get the opportunity to ask some questions at the end, I hope. So CondAlign wants to provide a solution for these questions that have been asked for several years about how can you actually bond components to this flexible substrate and temperature and pressure sensitive substrates. So we believe we have the answer by enabling electrical bonding at room temperature and low pressure in flexible hybrid and also printed electronics. We are a technology company developing and producing groundbreaking electrical and thermal anisotropic conductive materials. Today I will talk about the electrically conductive materials, but by doing so, connecting electronics and transferring heat. We're based in Oslo, Norway. We have in-house R&D, product development, and pilot production, which is based on our extensive IPR portfolio. We are 22 employees now, and actually last week we got our ISO 9001 certificate. So this technology, which everything is based on, is in principle very simple. It's based on dielectrophoresis. So what we do is we mix a small amount of conductive particles into a liquid resin. Then we bring this into a coating line between two liners. We expose it for an electric field. Electric field will induce dipoles in the particles, and they will align into chains in the C direction through the material. And when that happens, we cure the material, we use UV curing, and at the end of the process, the final product will roll out. So for the resin or for the polymer, we use an acrylic-based PSA. For the conductive particles, we use silver-coated glass. And this process is very well suited for high-volume roll-to-roll manufacturing, so which makes it a very efficient and also cost-efficient and time-efficient process. Fits into multiple applications, and there are two little different applications you see here. Take them first as EV powertrain, so actually temperature management in EV vehicles, and there is a thermal management in electronics. And those are based on if you swap the electrically conductive particles with thermally conductive particles, we make thermally conductive films or thermal interface materials. But today I'll talk mainly about the electrically conductive films, and those go into like flexible electronics, microchips, RFID, displays, smart labels, and LEDs, and I have a number of examples of that later in the presentation. So how does it actually work? And since a few pictures or a short video will tell you more than 1,000 words, I just start the video where it shows that we will bond a flexible battery to a PT substrate with silver print on. It's pre-bonded LED, which we light up when we bond the battery. So let's go. You cut the piece, remove one liner, place the tape on the substrate, light pressure with a squeegee, remove the second liner. This is all in laboratory environment, so in industrial environments it will take a little shorter time. But here the bonding is accomplished, and you see the LED light up. So as you see, no post-curing, just using the tape as a double-sided tape, providing both mechanical and electrical bonding. So what are the competitive advantages with this? So one very important